are learning about what are called rational expressions. So in mathematics, rational means fraction, and an expression is just something with variables and numbers in it. So your assignment is 3.1 in ALEKS, and the first question says find all excluded values. So basically it wants to know which y values am I not allowed to plug in. And there are only two ways to plug numbers in and then create non-numbers. The first one is when you square root a negative. Then you end up with a number that's not a real number. Okay? So square rooting a negative is not allowed if you are restricted to the real number line. The other way is to divide by 0. So what number can I plug in here that will create a 0 in the denominator? 10. So y is not allowed to be 10, and the way you do that, you just set it equal to 0, and then we get y equals 10, which means when y is 10, the denominator is 0. Why are you not allowed to divide by 0? Because it's undefined. You guys spent way too much time in junior high or middle school. You guys went to middle school, huh? You went to both? Oh, okay. So undefined is a middle school teacher's, math teacher's way of saying I'm too lazy to explain it to you. Same with junior high teachers. They're all the same. Yep, just lump them all together. So the reason you cannot divide by 0 is because you don't have enough time to do it. So if you have a 48-inch stick and I tell you cut it into pieces where each stick is 2 feet long, how many pieces will you get? 24. Or sorry, 24. That's for 2 inches. We'll get to that. So 2 feet, you take a 4-foot stick, you cut it into 2-foot lengths, you get 2. Right? What if I tell you to cut it into, let's do something. Let's have a 12-foot stick, and I say cut it into pieces 3 feet long. How many pieces will you get? 4. What if I say cut it into pieces that are 2 feet long? You get 6. What about 1 foot? 12. What about half a foot? 24. What about a fourth of a foot? 48. And the smaller and smaller I cut those pieces into, the more and more pieces I get. So essentially, if I say 12 divided by 0, I'm telling you, you have a 12-foot stick, cut it into pieces so that each piece has no length. How many pieces will you have? An infinite number. And what's going to happen is you're going to chop all day, right? And I show up and I say, Addie, how you doing? And I look and I pick up a piece and I say, nope, I can still measure it. Keep chopping. And I go away for a week or so and I come back and Addie's been working. She's all sweaty, hasn't showered, and she smells, and she's been chopping. It's just like every Thursday, right? And then I pick up a piece and I say, nope, I can still measure it. You need to keep chopping. Okay, will she ever be able to fulfill my request? No. But where are we headed? We're headed to infinity. So then let's do something easy. So 12 divided by 1 is 12. 12 divided by 0.1 is 120. So that means every piece is 0.1. It's a 1/12 of a foot long. Well, 12 divided by 0.001 is 1,200. Well, 12,000. Do you see what's happening? If the bottom gets smaller and smaller and smaller, then the answer gets bigger and bigger and bigger. So when I ask you to do this, the answer is going to be infinity. Now, we'll never get there. But if you try this in a calculator, oh, sorry. So 12 divided by 0, it says error. What the calculator is really saying is, I'm too lazy to do that division, right? Because the answer is infinity. Uh-oh, he's not wearing a mask. It's okay. Term started over, so you get 2 freebies again. Nice. All right, so that's why you can't divide by 0, because 12 divided by 0 is infinity. Now, this is a little bit weird. It's also negative infinity. Well, it depends on if your 0 is positive or negative, right? Because 12 divided by 1 is 12, and 12 divided by 0.5 is 24, and 12 divided by 0.1 is 120. But what if I change those to negatives? So 12 divided by 0 is simultaneously infinity and negative infinity. Whoa. Too much. Too much. Okay, that's enough. We'll be finished. That was problem 1. Problem 2 will be much easier. Won't involve that much of an explanation. Okay, so this is asking, what am I not allowed to plug in? Well, all we're worried about is the denominator equaling 0. So I'm going to pretend that... No, I got to turn my pen on. I'm going to pretend that this doesn't exist, and I just want to know, when does the denominator equal 0? This looks like a quadratic equation. What do we do with quadratic equations? We factor. Are there 2 numbers that multiply to be negative 35 and add to be 2? Positive 7 and negative 5. So we set each of those equal to 0, and we get u equals negative 7 and 5. Now, what do those numbers mean? If we plug in 5, something will happen on the top, and 0 will happen on the bottom. And anything divided by 0 is undefined. So u is not allowed to be negative 7 or 5. Okay, but this question says, just like the last one, find the values for which the expression is undefined, which is why there's an equal sign right there. The expression is undefined at negative 7 and at 5. Okay? Which means those are the numbers I'm not allowed to plug in. Because I get infinity, and I don't know whether it's positive infinity or negative infinity, and I don't know how to graph it. So that's a really good question. What is happening at 5? So one of 3 things is happening. Okay? Most of the time, the graph looks like this. Like that. Or it could be upside down. Okay? And you'll notice the closer and closer I get to 5, the closer and closer I get to infinity. Or if I'm on the other side, the closer and closer I get to 5, the closer and closer I get to negative infinity. Okay? And of course, it could be the same thing in reverse. Right? Or sometimes, let's do green. Sometimes it actually looks like this, where both sides are going in the same direction. Well, the fact... so anyway, those are the 2 things. So one, the edges could be going in opposite directions, or they could be going in the same direction. Every once in a while, you'll have a graph that goes along. Okay, I don't know what it's going along, and then at 5, it just kind of disappears. And your calculator won't show that to you. And that the reason I'm explaining this is we're going to learn that in the coming days. Okay, so if 5 cannot be plugged in, there are 3 reasons why. Either there's a vertical line there and the graph goes in opposite directions, or it goes in the same direction, or it just jumps over it. So with this graph, your calculator's not going to show you that gap. But you could plug in 1, 2, 3, 4, 4.5, 4.9, 4.99. All of those work. But when you plug in 5, you don't get an answer. Okay? And sometimes that happens, but we're not going to look at that today. So either there's a vertical line at 5 called an asymptote, or there's a hole, which means there's just a missing chunk of the graph right there at 5. Yes, at that point. Right? But the area around it does not go. Oh, I did, huh? It's his fault. It's his fault. I'm a liar. Okay. So let's look at number 3. Number 3 just wants to know what is h of 5. So we plug 5 in for x. Turn on my pen. 5 minus 9 over 3 times 5 plus 3. So negative 4 over 15 plus 3 is 18, which simplifies, nope, negative 2 over 9. Piece of cake. See how short that was? It's true. Okay, except on the hyperbolic plane, they do get closer and closer and closer. No. All right. So this says, no, hyper and hyperbolic are two different things. You mean hyperglycemic? No, hyperglycemic means you're diabetic. You cannot, means you have too much sugar in your blood, usually because you can't process. No. Well, hold on. Hold on. We don't need to record. So, number 4 is exactly the same thing as number 2. It just wants to know which numbers are not part of the function. So we set the bottom equal to 0. We factor x plus 6 and x plus 2. So x equaling negative 6 and negative 2. Those are not allowed. Okay? Now, normally when we do these, we write x cannot equal, but Alex is asking the opposite question. It's not saying what does it equal, it wants to know what does it not equal. So the question has a negative in it, which means the equal to is part of our solution. Nice try. Okay, number 5. Okay. So we need to plug in x minus 1. So that gives us 5 times x minus 1 squared minus 3 times x minus 1. Can you square this in your head? So it's going to be x squared. So we get 5 times x squared. And then I get 2 copies of this. One of them is x times negative 1, and one of them is negative 1 times x. So it's just going to be negative 2x, and then negative 1 squared. Distribute the 5, and then simplify. Okay? You'll just have to type it in. Okay, number 6. Okay, so what do we do here? Well, let's factor the denominator. So I get x minus 3 over x minus 3 and x plus 3, because this is a difference of perfect squares and it factors into conjugates. Does anything cancel? Now, never, ever, ever are you allowed to do something like this. Okay? You have to count those in factors. So what we basically have is A over A times B. Right? You can't cancel part of A. It has to come as a group. Okay? So you cannot, if the bottom is made up of multiplication, well, you cannot cancel a partial factor with something over here, but notice that x minus 3 and x minus 3 match, and we get 1 over x plus 3. Oh, hang on. Let's see what number 7 looks like. Okay, so that's a good question. So this is what I was talking about. You can't say, oh, x cancels x and 3, then I would get 1 minus, or sorry, just 1 over x minus 3. It doesn't work that way. Okay? You have to, you cannot cancel a portion of an addition or subtraction. The only way to cancel is to cancel multiplication. So if I have a plus b over a, there's nothing I can do, right? But if there's an a over here, then I can pull out an a, and then I have 1 plus b over a, and now I can cancel. You can never cancel a part of an addition or a subtraction. It's just not doable. And it will make a little bit more sense in the last problem. So you might look at this and think, oh, look, 8 goes into 24 3 times. No, not allowed to do that. You cannot cancel a portion of a polynomial using addition or subtraction. So what you have to do is factor the top, they're v's, v plus 4 and v plus 2. And then on the bottom, I'm going to pull a 3 out. If I take out a 3, I get v squared plus 2v minus 8. And I get 3 times v plus 4 and v minus 2. You see that? Now, the v plus 4's cancel, and I get v plus 2 over 3 times v minus 2. And my bet is they want you to put this back in. V plus 2 over 3v minus 6. My guess is that's what the answer is going to be. But there is a chance that they do it this way. Probably not. Or, if the program's really smart, it will let both of them go. These are not exactly the same. One's a plus, one's a minus. So this is probably what they want. Did you try? Well, let me try it then. I'm going to do it from my computer. It'll be easier. All right. So v plus 2 and 3v minus 6. Yeah, that's what it wanted. Your problem is probably different from mine. Yeah, they're random, so. Okay. Any questions? All right. Get to work.